This course comes to you from Shield Guardia. We build security software, and we train the people who run it. This is SOC Analyst for complete beginners. Episode 5. Today we take apart 5 real breaches. First, we look at how long attackers stay inside before anyone notices. Then the 6 steps almost every attack follows. Then we walk through Target, SolarWinds, and Equifax, one step at a time. After that, 2 attacks from this year where an AI agent did the attacking work. At every step you will see what the attacker did, what the company missed, and what Aegis would show you today. Here is the thing that surprises people. Attackers do not break in and leave the same day. They get in quietly and stay for weeks or months. Target had them for 19 days. Equifax for 76 days. SolarWinds for over a year. And in 3 of the 5 cases today, the alarm actually went off. That waiting period has a name, and it is dwell time. Dwell time is the number of days between an attacker getting in and the company finding out. It matters because the attacker spends those days looking around. So a small break and becomes a huge breach. Look at the numbers on screen. 76 days is long enough to copy the personal records of 147 million people, which is exactly what happened at Equifax. So every day you cut off the attacker's stay is data they never get to take. Now, attacks are not random. Almost everyone moves through the same 6 steps in the same order. Get in, move deeper, install their tools, find the valuable data, take it out, and stay hidden while they do it. And those 6 steps matter because each one is a separate chance to stop the attacker. Miss one, and they simply move to the next. So when alert lands, ask which step it belongs to, because that tells you how much time you have left. Now, let us use that. Here are 5 real breaches, and you can step through any of them. Pick a case, then advance the timeline 1 step at a time. The first 3 cases are the classics, and the last 2 happened this year. So start with the Target case in 2013. Step 1. Attackers phish the company that services Target's air conditioning and steal its login. Nobody was watching that supplier account, so this went unnoticed. Step 2. That stolen login opens an internal system, and from there they reach the payment machines, because nothing separated the 2 networks. Watch the panel at the bottom. Aegis knows which machines each account should touch, so a supplier account reaching payments is an instant alert. Now, step 4, and this is the one worth remembering. Target's security tool did detect the attack, and it did raise an alert. The team in Bangalore escalated it. But the team in Minneapolis looked at that same alert, decided it was a false alarm, and closed it. So the tool worked, and the process failed. That is why Aegis escalates on its own when a critical alert stays open, because one wrong decision should never be able to bury an attack. So that closed alert cost them 19 days. A journalist found the stolen cards for sale and phoned Target, and that is how they found out. Any one of those earlier alerts would have ended it on day 2. Next case, SolarWinds. This one is different because there was no obvious break-in. Attackers got into the machine that builds the software and added their own code to it. So the update that shipped from that machine was correctly signed, and it looked completely genuine to 18,000 customers. And that signature is the lesson here. A signature proves who built the software, and it proves nothing about whether the software is safe. So Aegis watches what a program does after it installs, and it flags a quiet outbound connection running on a regular timer because that is how attacker control channels behave. Now, the last case, Equifax, and here the failure is simpler. A serious flaw was announced and a fix was released. Equifax sent an email asking teams to patch it. One internet-facing server was missed, and nobody checked that the patch had actually been applied. And that missed server gets worse. The Equifax tool that inspects encrypted traffic had an expired certificate, so it had been watching nothing for 19 months. Aegis monitors its own inputs and alerts when a source goes quiet, because a silent tool looks exactly like a safe network. Someone renewed that certificate on the 29th of July. Inspections started working again, and the theft was visible within one day. 76 days of quiet theft ended in 24 hours because one tool was switched back on. So those are the classics. Now the fourth case, and it is from this year. Between December and February, one operator broke into 9 Mexican government bodies, including the tax authority. They got in through a software flaw from 2010 on a public server nobody had patched. And here is what makes this case different. The operator did not do most of the work. An AI coding agent did. Investigators recovered the logs from the attacker's own machine. Those logs show 1,000 human instructions turning into more than 5,000 commands across 34 sessions. So look at step 2. The agent found a scheduled job it was allowed to write to. It added a key so it could log in as the top-level account, then put the file's date back to hide the change. Aegis protects those files and alerts on any write, even when the date is restored. But here is the part worth remembering. Not one move in that attack was new. Writing to a scheduled job, adding an SSH key, tunneling out, reading every database. Ordinary controls detect all of it. The AI only changed the speed, turning weeks of work into hours. And nobody caught it. No victims spotted anything. So it took outside researchers about 60 days to find the attacker's own servers and warn them. That is the lesson here. Write detections for the behavior, because a rule that watches a scheduled job does not care how fast the attacker types. Now the last case, and this one is 4 days old. Somebody took over the account of a developer who maintains a small package called Kiev. Nothing famous, but about 127 million downloads a week because thousands of other packages depend on it. So they published a poison version of Kiev. It carried a valid signature, so every automatic check passed. That is the SolarWinds lesson again. Only this time it was 4 days ago, not 6 years. But the third step is the new part, and it is worth your full attention. The package wrote commands into the settings files of the developer's own AI coding tools. After that, nobody had to install anything. Simply opening the project ran the attacker's code again. And think about what that means. You treat a settings file as harmless, because settings are just preferences. But a settings file that can hold a command is code. Aegis watches those config folders on developer machines and alerts the moment a startup hook gains a command. Then the payload swept the machine for secrets. It checked 290 kinds of file, looking for cloud keys, login keys, and published tokens. It sent those out. Then it used the stolen tokens to poison hundreds more packages, which is how one account became 444. And one more thing about this worm, because it could catch you personally. It leaves a watcher running that starts attacker code the moment a token is canceled. So if you find this on a machine, remove the hooks and the watcher first. Cancel the tokens after, because the other order sets it off. So why does speed matter this much? Move the slider and watch the cost climb. It does not rise steadily. It jumps because once attackers have time to find the valuable data, they take all of it. So every rule you follow at work was written after a breach like these 5. Target gave us the rule that a critical alert cannot be closed without a written reason. SolarWinds and the Kiev worm both gave us the rule that signed software still gets watched. Equifax gave us the rule that you check your own tools are still running. And Mexico gave us the newest rule of all. Write detections for the behavior, because behavior does not care how fast the attacker moves. Before you go, a quick word about the tools behind this course, built by our team at ShieldGuardia. Aegis is the security platform you saw today. It watches every machine, catches the attack, and cuts it off. Strata is for after the incident, when you need to know what happened and in what order. NSA is our bug bounty workspace for finding your weaknesses before an attacker does. So here's what to carry away. Attackers stay for weeks. They follow the same 6 steps every time, and that has not changed now that AI is doing the typing. What changed is the speed, so the same 6 steps arrive in hours instead of weeks. Your job is to be the person who acts. The full course with hands-on labs is at Cyber Education. See you on shift.